Good morning, everyone. Today, I'm excited to introduce WasteWatcher, an innovative platform designed to revolutionize waste management analysis. For the project overview, at WasteWatcher, we're tackling the global warming issue head-on by providing comprehensive tools for waste management analysis. Our platform serves as a vital resource in understanding and addressing the challenge posed by waste production. For the background and motivation, currently our world is affected by global warming, with waste being a major contributing factor. This project seeks to examine the correlation and impact of weather on waste production. By understanding how weather influences waste generation, we can develop solutions to address the global waste issue. For the overall architecture, we established a connection between KitBright and the ultrasonic sensor, enabling the transmission of waste data to the MQTT server. And Node let retrieve waste data from the MQTT server and also gather weather data from the weatherapi.com, subsequently recording it to the database. The web application then retrieves this data from the database for further analysis and visualization. For the primary data source, we utilize the ultrasonic sensor to obtain the waste level in the bin. It is positioned beneath the bin lid and connected to the KitBright. KitBright sends the waste level accumulated in the past hour to the MQTT server. Subsequently, Node-RED retrieves the data from the MQTT server and record it in the database. For the secondary data source, we utilize weatherapi.com to obtain weather condition data. Initially, Node-RED retrieved weather condition data via API from weatherapi.com. After that, it stores the select data including temperature, precipitation, and humidity of each hour into the database. For the database schema, we organize the data into three tables: bin, waste, and weather API. The bin table contains information about the bin, including the bin ID, name, location, waste type, capacity, and collection frequency. The waste table collects data on waste level. The weather API table gathers data about weather conditions such as temperature and humidity. Once all the data is collected in these three tables, we integrate it into a single table named waste record. This table consolidates the data from the three tables into one unified record.
For our data sharing API, we provide the user with 14 API endpoints related to bins information, our waste records, along with their corresponding weather conditions. The user can also retrieve the latest record from our database or even the specific period of time that they want to learn about. Let's go to some example of the API endpoints. First, /API/bins. This endpoint returns a list of all bins available, including their unique ID, name, location, latitude, longitude, waste type, capacity, and collection frequency. Next is the API endpoint /API/waste/latest. So in this endpoint, we retrieve waste and weather data for all bins for the latest days. This endpoint returns a list of aggregated waste data and their corresponding weather information for each bin for the latest date. And lastly, the /API/waste/year/month/location and /location. So in this endpoint, we retrieve the waste and weather data for the specified location and month. This endpoint returns a response containing waste and weather data for the specified location and month, including details records of waste level, temperature, precipitation, and humidity. For our data visualization, we provide the users with interactive line charts using chart.js to visualize the trends of waste levels and weather conditions over time. The users can select the time period to visualize, including yearly, monthly, or daily. And this visualization aims to offer insights into the relationship between waste generation and weather conditions. Next, I'll show you the demo of our application. This is the demo for our web application. So first, let's go to the latest Waste page. So in this page, the user can specify the location or bin ID and the bin or location that they want to see. It will show the latest record from our database, including waste level, timestamp, temperature, precipitation, and humidity. It also has the 4 line charts to let the user visualize the trend of waste level, temperature, precipitation, and humidity. So let's go to the next page, waste level comparison. So in this page, the user can also specify the filter type, but the user can also specify the period of time that they want to see. So let's try. As you can see that the data will show in the specific period of time that the user already specified for the specified location or bin. It will also have the table to show the records, including the aggregated value from this period of time. And lastly, our API documentation. This page will use the Swagger UI to let the user explore our API endpoint. So let's try the first one. Here, the user can see the response body and the schema for that particular endpoint. And that's it for our demo. Thank you for watching and have a nice day.